Hello students, I am Dr. Saleha Jamal, Associate Professor from the Department of Geography, Aligarh Muslim University, Aligarh. So dear students, welcome to the class, and today we are going to discuss the basic spatial analysis tools. Till date, what we have discussed the concept of what is spatial analysis. We have also discussed the types of spatial analysis. Mainly, we have discussed in that types we have discussed 6 categories of spatial analysis, if you remember. Then we have also discussed with the applications of different spatial analysis, we can say, in different discipline and also in generalized manner. But whatever application we have seen, such applications are performed by various techniques and tools that is related to the spatial analysis. So considering that thing to make you understand better, today I am going to discuss the basic spatial analysis tool, and today's class have the content which will be discussed now. That is, we are mainly dealing with the basic tools of spatial analysis. Just for example, we will deal with the extract tools. In extract tools, we have the tools like clip tools, select tools, and the split tools. Again, we have the proximity tools. The proximity tools consist of, generally we will be discussing the major one which are mostly used in spatial analysis, that is the buffer tool and we can say near tool. Then there are other some important tools like overlay tool, intersection tool and union tool. So these all tools will be discussed one by one. So these tools are generally present in different softwares. So mainly specifically the most important one is, everybody you must be now aware with the geographic information system. It provides such environment by having the different tools which we can use during the spatial analysis of various spatial phenomena, spatial features, spatial objects, etc. So we know that generally these basic tools are used in a geographical information system and they are used to extract different information, the information which is usable. We know that the spatial data is existing, like spatial data in form of remote sensing imageries, satellite imageries are existing from long back. And this is such a voluminous data, and extracting the usable information according to the need or according to the set criteria was a big task which can be solved through using these tools in GIS environment. So with the help of these tools, we can create new data sets from the voluminous data sets. We can even create the subsets, we can say, and we can manipulate, modify the data sets according to the set criteria. So actually these tools are invaluable for isolating and working with the relevant portion of spatial data what we are having. Thus these basic tools play a very important role in spatial analysis. So dealing with the first tool, that is the extract tool. If we consider the extract tools, as the name is suggesting, that we are extracting something, taking out something. So similarly, being the literal meaning that we are taking out something, clipping something, here also extracts tool has the same function. It clips out certain set of information from the larger data set, from the voluminous data set, and these information is generally extracted according to the set criteria, I can say, or according to the need, according to the study, whatever you can say, students. So this actually extract tools allows mainly the users to create the subsets and new data sets and the manipulation of the data sets. It also, for example, suppose we have to extract all buildings above certain height. If we are having the voluminous data of different parcels, or you can say different buildings having different sizes, and we set a criteria of particular size and we want to extract the building on all the buildings on the set criteria, that function can be performed through the certain extract tools. So these tools generally forms subsets, and it creates such type of data which can be used for further analysis. So we have various tools which comes under the extract tools. We'll be discussing the clip tools, select tools, and the split tools. Now, you can see on the screen here, I am discussing with the clip tools. If you see the clip tool, again I would like to say here, clip, to take out something, to cut out something. In clip tool, actually we cut out a portion of spatial information using the boundaries of another data set. Means if we are having the larger data set or certain input layer which we are providing to the GIS environment, that input layer, from that input layer we are going to clip out. We are going to clip out from the larger portion, we can say, according to the set criteria or need, we are going to clip out or cut the portion which actually we need. So if we are taking the if we are taking from the layer a smaller portion of data set, then it is but obvious that this clipped out layer will retain the characteristics of the input layer, because it has been clipped out of the larger input layer, we can say, or larger data set. For example, if one want to clip out the vegetation zone or vegetation cover from the protected area, suppose the protected area size is this much and we have to just clip out the vegetation cover which has the size smaller than the, obviously, than the protected area. So that will have the property of the input layer. That vegetation will certainly have the property of input layer. So actually this tool is very much valuable for refining data sets to the specific spatial context, and mainly for overlaying the data sets in order to analyze different types of existing relationships, different types of trends that is existing on the we can say in spatial data. So at clip tools, you must be now clear about the clip tools. Clip tool is one of the type of the extract tools where we cut certain portion of the data set from another boundary data set and another boundary data set. So this is the main I can say main role of clip tool. Another, I can say here, another tool will be discussed. This is the select tool. Again, I would like to say select. The name select means we are highlighting something, we are pointing out something. In this we are pointing just the specific things, that things are highlighted and rest of the things are generally not shown. So with the help of this select tool, we identify and highlight different features in the spatial data sets. May we want to highlight the buildings of that is built in particular year. So means there are lots of buildings which have been constructed in different years, but on the set criteria, suppose we have to select all the buildings which has been constructed in 2003. So 2003 is the set criteria. So we are going to select all those buildings which is constructed in 2003, and rest of the data we are not going to use. So basically the select tools is simply used to identify and highlight the spatial data set according to the set criteria. We use this feature in order to meet the given criteria, whatever the criteria is. Like we have discussed, the criteria is that we are going to select the buildings that is built in 2023. So this tool generally aids in data exploration, in identification of relevant features for further analysis. This tool exactly helps, and it creates such data sets, such subsets, or make ready the data sets for the further analysis. Thus, it is also one of the very important extract tools. Coming to the split tools. Split. The word split. What does the word split mean, students? The split means we are breaking something. Splitting something means this is the data set and now we are splitting something, and this breaking something is what we are talking about: the spatial information, spatial features, spatial location, spatial data sets. So here we are splitting the spatial data set into multiple set, or we can say we are generally breaking or splitting the input layer of data set into multiple layers. Maybe we can break it into 2 part, 4 part, 8 part according to the certain criteria. And it is this we can say the set criteria, it may be commonly used in the partition of the polygon feature, maybe in the partition of the line to make certain segments, in the partition of the polygon feature to make different areas, or according to the whatever the set criteria is. For example, if we want to split the road network at certain intersections in order to create different segments, for that we can create this through the splitting by using the splitting tools. So generally here what we are doing, we are modifying the input layer, we are manipulating the input layer, because we want different we want the complete data sets in different parts. So in such smaller parts, that is more manageable rather than having that data set in larger portion. So if the input layer or input data is so big and we are breaking it into smaller portion according to the set criteria for better managing that data set. So split tools also play a very important role. So dear students, you can see on the screen here, if you see these are the different extract tools that we have discussed. That is the input, we can say clip tools, select tools, and the splits tools. You can see here the input tool. The input layer. This is the input layer. You can see in square. This is the input layer. In clip tool, what I have said, that is a portion of data set is clipped out or taken out from the another input layer or another boundary. So you can see this is the boundary of input layer or input data set, we can say, and here we have clipped out this certain portion according to the set criteria. There, if you remember, I have given which example. Suppose this is the protected area. Just suppose this is the protected area and we want to clip out the vegetation zone. So this is the clipped area, we can say. Another tool, select tool, what I have said, select tools are generally used to highlight the certain portions or the selected data set, or to point the certain portion for and which makes data ready for further analysis. So again you can see here, this is the input layer. Here we wanted to highlight only pink parcel. You can see the pink parcel of the data set, pink portion of this input layer. So just we have selected the pink portion of this layer. So this is the output now. So this will also retain the characteristics of the input layer. Again the split tool, you can see here the split tools. In the split tool, what we have done, we have broken the input layer, we have split the input layer into different layers. From one layer we have formed the multiple layers. That layers may be formed according to the set criteria, that how much layer we need for further analysis. So this extract tool is one of the among very much basic tool which creates such data sets, such subsets for further analysis. Now coming to the another tool that is very much important, and generally it is used in lots of functions. It has multiple applications. That is proximity tools. Proximity meaning we are talking about the vicinity of something. We are talking about the vicinity or we can say vicinity of something, or even the surrounding of something. Something is what? That may be our point feature, that may be our line feature, or that may be our area, or we can say polygon feature. That may be anything. So vicinity of that feature. If you're talking about the point feature, the vicinity of that feature, or we can say the surrounding of that feature, that is what proximity. So in demarcating the vicinity or the surrounding, we need generally this proximity tools. So proximity tools are generally used to mark the vicinity, or we can say the surrounding. For what purpose? To analyze the relationships. Actually, the particular types of relationship, that is distance between the features. One feature will be the input layer, and from that input layer we have to see the distance up to the output layer. For example, there may be the input layer is that we can say the certain school. The input layer is the location of school, and we want to find out with 2 kilometer distance from the school, we want to demarcate in order to plan for silent zone, or we can say no horn zone, and maybe restricting certain activity to 2 kilometer distance. Means 2 kilometer is the set criteria, and we will demarcate the boundary around that point feature, that is a school. We are going to demarcate 2 kilometer of boundary in order to plan for that particular spatial unit, that it should be the demarcated no horn zone, or we can call it silent zone, or certain activities will be restricted in this 2 kilometer of diameter around the school. So thus we can say actually the proximity tools are generally used to demarcate or certain distance from certain features, maybe the input feature, and this distance may be demarcated either around the point feature, line feature, or maybe the polygon or area feature, we can say. So basically these tools helps to understand the spatial distribution, we can say the distance among the features, and it also helps to understand the connectivity between the features, or we can say proximity of features. When we many times we talk about the nearby features, various time we go somewhere and we used to scroll, we used to search nearby restaurant where we are when we are at particular location, what are nearby restaurants. In some time in emergencies we search what are the options of nearby hospitals. So these all functions can be performed from this proximity tools. So here I would like to discuss some of the proximity tools. The first important proximity tools is that buffer. Actually, buffer is what? It creates a certain boundary, the boundary zone, that is known as the buffer zone, around the feature, specifying a particular distance. For example, again here I would like to say, so suppose there is certain road, a road, and we want to demarcate, or we can create a boundary with 500 meters all along the road. 500 meters all along the road means what we are doing, we are the specified distance is 500 meter, and we are creating a buffer zone around the road with a distance of 500 meter. Thus it creates a buffer, I can say. So this buffer zone may be represented either around the circular feature or maybe the polygonal feature. That will dependent upon the geometry of the input feature. For example, road will be represented by the polygonal shape, and cricket ground will be represented by the circular shape. Means the geometry of the buffer will depend upon the input feature. So if the boundary of the input feature is very much erratic, then the buffer of that boundary will be also erratic in shape. So it's totally depend upon the input feature. This I can say the buffer tool, it calculates and it creates a new geometry that is very much related to the input layer. When it comes to how these buffers are generally drawn, you can see the screen, students, now here. This is the point feature around which we are taking a certain set criteria, and we have drawn this buffer. If you see here on the screen, we have drawn this buffer around this. And finally, certain features, you can say certain spatial unit is overlapping on each other, so it may be dissolved, and final only outer boundary will be received. Again, this is the, you can see here the line feature, and you can see here the line feature. Again, few of the spatial unit is a small portion of spatial unit overlapping. You can see here on this buffer is overlapping, so we can dissolve this and we can form a single just outer boundary buffer for this type of line feature. Similarly, for the area feature, we can see here, this is the buffer drawn. You can see on the screen, student, this is the buffer drawn, and here you can see around, again there is overlapping. You can see this overlapped area will be dissolved and only the outer boundary will be retained. So this is like this. We can draw several buffers either for the point feature, line. Another proximity tool is the near tool. Near tool, finding the things nearby simply, or we are showing the features that is nearby, that is known as near tool. And it is as I have said, all these tools are generally present in our geographic information system, that is in GIS environment. And near tool is also one of the powerful spatial analysis tool which generally calculates the distance from each feature in one data set to the nearest feature of the other data set. Means here we are having two data sets. So what actually the near tool, how the near tool functions, here it calculates the distance of features in one data set to the, we can say, the features of different data sets. Actually calculating the distance means finding the nearby places. So this tool is basically, for example, what I have said, that if we have moved or traveled to some new places, so we can find out the nearby hotels, the nearby restaurants, or nearby interesting places to visit. Everything can be find out through this near tool. So basically this tool is useful in spatial analysis and also in decision making processes where proximity or distance plays very important role. So in proximity tools, we have studied two tools mainly. That is one, what is that, a buffer tool, and another is near tool. You can see here on the screen that we can have the near tool for point to point feature. The input layer is a point feature, and the output layer is also a point feature. Even we can have the calculate the distance between the input feature to the point to line, means input feature is point and output feature is line. Even we can have point to polygon nearest distance. So this you can see here, mainly it is used. Then functionality, what are the functions of this near tool? It calculates the distance of the nearest data set, or simply from the one input feature to the other input feature. It creates, it adds new attributes to the input data set, means the output of the near tool typically includes all the attributes in the input data set, storing the distance to the nearest feature. So that is also one of the most important function. And options, we get certain options of the near feature in order to consider the maximum search distance. So even we can get the options. So these are the various functions, and where it can be used. Just we have studied about the buffer tool where it can be used. Similarly, the nearness analysis can be used for facility planning. For example, for determining the closest hospital to each residential address in city in order to optimize the emergency response. If some residential areas in emergency response is needed, so nearby hospital, planning for the nearby hospital, that can be used in facility planning. Similarly, it can be used in resource allocation. For example, determining the nearest fire station to each neighborhood to optimize the fire response services. This is what we can say resource. We are allocating the resource nearby locations from the each residential areas. It can also be used in environmental analysis. For example, assessing the distance of residential areas from the contaminated sites. So what will be the effect according to the distance? That all can be analyzed if we are going to calculate the distance between the residential area and the contaminated site. This is also used in tourism and recreation, this nearness analysis. If you see the use for identifying the nearness point of interest, hotels, recreational facilities to tourist destination, enhancing the visitor experience, all that can be used. So basically what we have studied, we have studied the extract tools and the proximity tools. Coming to the third type of tool, that is the overlay tool. Overlay, it means that we are superimposing, or we can say we are overlaying one layer upon the other, according to the set criteria, in order to get a new subset, some sort of new information, whatever that is required. Suppose we have to plan for transportation network, that is road. So we may have one layer, I can say, suppose you can have the layer of topography of that particular place, another layer of existing road network, another layer of congestion points on the road network where traffic jam usually take place, another point of some vacant or open spaces. So by overlaying all these things, you can get certain information that where new road networking can be planned in order to minimize the congestion or traffic jam, we can say, for the particular place. That is what we can say overlaying. After overlaying, we are creating a new data set, we are modifying the data set. So basically the overlay tool in GIS, here you can see the screen, this is the overlay tool. You can see here the spatial analysis tool. Among the GIS environment, we have lots of tools. Among this, you can find here the overlay tool. You can see on the screen. So basically this overlay tool in GIS is a spatial analysis technique mainly used to combine multiple layers of the spatial data, what I have talked about. It creates a composite map. If we are overlaying and we are finding out something, means we are combining all these layers in order to get a composite map by combining the geometry and even the attributes of the input data. We are combining everything, the geometry of the input data and even the attributes of each input data that has been combined. So a new data set is created for further analysis. For example, we can say n number of layers. Here you can see we have taken here 4 layers and we have combined all these layers. We have combined the geometry of these layers and even all the attributes of these input layers, and final the combined layer. We have received the combined layer for further analysis. For example, in example you can see this is the identification of environmentally vulnerable neighborhoods utilizing overlay analysis. For example, we can have multiple layer, because we are identifying environmentally vulnerable neighborhoods. So for environmentally vulnerable neighborhood, there may be n number of set criteria. Maybe environmentally vulnerable spatial unit may depend upon, we may have one layer of facilities existing in the area in terms of the hospitals. We may have another layer in terms of the street lights. We may have another layer in terms of the presence of the school. We may have another layer to see the water supply of that particular region. We may have another layer to see the sanitation facilities which are existing in that region. We may see the drainage system of that region. So by combining all these layers, we can have the composite layer, and accordingly we can assess the areas which are more vulnerable, environmentally vulnerable. For example, here we have found that most vulnerable zone, red portion you can see here, that is the most, and green one are the least vulnerable. So by combining all this data feature, the input layer, we get the composite layer. So here how we can say the overlay tool works. So coming to the another important tool, that is the intersection tool. Intersection tool means something intersecting, that is overlapping on each other. We can say suppose you see my hands. This is the one layer, input layer, and another layer. Means a certain portion of the input layer is intersecting with another portion of the input layer, a certain input layer. So intersection tool is basically, it is a very much powerful tool used to analyze spatial data by identifying and extracting the areas of intersection, or where we can say where the features from two or more layers overlap. So suppose here actually we extract the areas of overlapping or intersection, the area of intersection. It will be more clear through the diagrammatic representation. Later I am going to explain it. So what actually, the first we will explain what is the functionality of that tool. Because when we are extracting the overlapped area, we may get new data sets. New data sets because the output layer or feature class that will retain the areas where from the input layers. Means if we are having the two layers, means it will retain the feature of the both the two layers in the extracted overlapped portion. We can clip the intersection portion, that is another functionality, and we can even not only geometrically we are intersected area we are clipping out, but we can have the attribute data or attributes of both this input feature. So basically here we extract out the intersected portion, intersection portion. Another tool, very important tool, is I can say here the union tool. Union tool, as the word suggests, as the word means, we are uniting something. Union tool means there are two input layers, we are uniting. Uniting means we are merging one layer with the other layer. In the intersection tool, what we have done, we have united the two layers but extracted only the overlapped or intersected portion of the data set. But here what we are doing, generally we merge the two layers, we unite the two layers. Means we are not extracting, we are including both the data sets, we are including the geometry of the both data sets, we are uniting even the attributes of both the data sets. So the union tool in geographic information system software combines the features from the two or more input layers, and actually it allows the users to merge different data sets with different spatial extent, and can also form the thematic layers into a compressive data sets. It can be seen, you can see here on the screen how the intersection tool worked. You can see two different input layer, one is circle and another is triangle. So here in intersection, what we have taken, we have just extracted the overlapped area. So this output is received. You can see here, this the output layer is received. So in another, we can see here the union. What does the union tool do here? Means we have taken one input layer, that is the triangle, and another input layer is circle. So actually it is uniting, it has merged both the input layers, and the output will be, and it has retained the geometry of the both the layers, plus we can say the attribute of both the layers. So the output will be in this form. Means we have combined, we have united here, and we have just clipped out the intersection portion of the data set. So thus how this works. So these are students, these are few of the basic tools I can say that visually we use in spatial analysis, and these basic tools, the GIS environment has very powerful capabilities of having this type of environment and including such type of tools which can perform n number of functions in order to get better insights from the data set, in order to extract usable information according to the set criteria or according to the need. So that's all for today's class, students. Have a good day. Thank you.